and welcome to the Whale Hunting Podcast, where we shine a light onto hidden worlds of money and power. I'm Bradley Hope, and this week I'm joined by Kim Zetter, an award-winning investigative journalist covering cybersecurity and national security, and author of Countdown to Zero Day, Stuxnet and the Launch of the World's First Digital Weapon. Welcome, Kim.
Thank you.
So, Kim, you're a longtime journalist covering cybersecurity and national security. You know, one of the things we wanted to really hear from you is about this whole Stuxnet story.
Yeah, so Stuxnet was a malware, virus/worm. It was a combination of the two. And it was discovered publicly in June 2010 after it started spreading around the world. But it was designed as a precision weapon to target computers in Iran at one specific facility that was controlling centrifuges that Iran was using to enrich uranium hexafluoride gas. And the malware was designed to affect those centrifuges in ways that would undermine the enrichment process. And because it had worm capability, worm meaning a worm is different from a virus in that it can spread without any interaction from the victim. So it gets onto one system and then automatically it searches for any other system that's vulnerable that's connected to the same network. And so once you unleash a worm, you really have no control over it and it will just spread wildly. And that's what happened with Stuxnet. It started spreading wildly out of control and started infecting systems across Iran, but also outside of Iran. And that's what ultimately got it caught.
Obviously, this is something that's been going on for many years. You wrote a book about it, Countdown to Zero Day. But it seems like it's one of those stories that doesn't quite go away. Could you explain why this is such a persistent story, or what are the mysteries around it that people keep wanting to know more about?
Yeah, I mean, well, it's a significant story just because it was the first example that we know of digital warfare. And it was such a brilliant operation in terms of the technical feat that it pulled off. And so it has this enduring interest in at least the cybersecurity community. I don't know about the general public, but the cybersecurity community sort of jokes about it, about 0 days since Stuxnet has been discussed somewhere in the world. Usually at conferences, it comes up all the time. So that's part of the reason why it's so interesting. With regard to the mysteries, there are still a lot of mysteries around it. We've uncovered at least one of them, and that is who got Stuxnet into the plant at Natanz. And so over time, hopefully we'll get more and more details.
Is this like is this worm one of those things that they could have released it anywhere in the world and eventually it would find its way to Iran? Or did they kind of try to infect some Iranian computers in the hopes of getting to these refining capabilities?
I don't think that you could launch it anywhere in the world and hope to get to your target. But they had two different methods of getting it into this facility. It was a facility called Natanz, or it's outside of the village of Natanz, the enrichment plant. And the systems there are not connected to the internet. So they are what we call air gapped. And so that makes it difficult to actually get something onto those systems. And the first time that the attackers unleashed Stuxnet at Natanz, they actually did it with physical access to the systems there. Not physical access themselves. They had a mole who delivered it to the systems there. But the second time they didn't have that access anymore. They unleashed it, we know, at least 3 times, probably more. And the first time was in 2007, and that's when they had the physical access to it. The second time that they unleashed it when it was in 2009, and there they used that worming capability. So the worm capability wasn't really in the first version. They added it to the second version because they didn't have that physical access. And in this case, then, they infected systems belonging to 5 companies in Iran that are in the business of installing industrial control systems. Because the attackers were targeting industrial control systems inside the Natanz facility. And so they were hoping that by infecting engineers at these 5 companies, that one of those engineers was going to be working inside the Natanz facility with access to the computers, and they would therefore unwittingly carry Stuxnet into Natanz. And that's exactly what happened.
And starting from the very beginning, was this a successful operation? Did they achieve their goals?
It was successful in the sense that the goal wasn't to cause one-time catastrophic damage, because that would be easily detectable and Iran would become suspicious and shut down the plant or do an investigation. The goal was to do incremental damage over time in a way that Iranian engineers wouldn't be able to determine what exactly was causing the problem. And in doing that over time, the intention was to degrade and undermine the enrichment process in order to buy time for sanctions to work and to convince Iran to come to the negotiating table. And so it worked in that regard because it did delay the enrichment process, and Iran did ultimately come to the negotiating table and sign an agreement. But of course, it was discovered, and so its life was shortened to what it probably could have achieved had it remained longer.
And in your reporting, have you discovered when Iran realized that this was the vector of the attack?
I gather that they probably didn't discover or really connect the dots until around November 2010. And the reason that I say that, Stuxnet was discovered in June 2010, and it was discovered by some people who work for an antivirus company in Belarus called Virus Blockada. And they had customers in Iran, and the customers in Iran started having trouble with their systems. I don't believe that they were machines in Natanz, but outside of Natanz probably. They were having trouble with the machines, and they asked this company, Virus Blockada, to remotely access the system and see if they could find the problem. Virus Blockada discovered the malware on the system and didn't really have the skills to fully take it apart, so they shared it with the rest of the security community around the world. And Symantec in the US started reverse engineering the code, and it took them a number of months to do this. So there were suspicions almost immediately that it was probably targeting Iran, but no one fully understood what it was designed to do or what systems in Iran it was targeting. So it took really that 3 months of reverse engineering the code for Symantec to connect all of the dots and determine ultimately that it was probably targeting the centrifuges at Natanz. And when Symantec published a final report in November of 2010, Iran took the Natanz facility offline. And so presumably then they were trying to clean out the malware.
Why is it called Stuxnet?
It's a name that Samantha gave it. It's just from parts of the code or parts of the naming construction that was in the malware itself. The attackers didn't call it Stuxnet, but some of the files, they took some names and put it together and named it Stuxnet.
And when everyone was looking at this code, it took them months to figure out what was going on. Was the conclusion that this was a truly kind of beautiful piece of code, or was it just the first kind of thing like this that was what's amazing about it?
Yeah, it was both because up until then, what we'd seen in the security world with breaches were things that were around cybercrime or espionage, nation state espionage. And in fact, when this was first discovered, people assumed that this was espionage. They thought that they knew it was targeting industrial control systems, but they jumped to the conclusion that because we'd only seen espionage before, that probably this was maybe some kind of industrial espionage. Someone was trying to obtain maybe blueprints at a factory, something like that. So we had never seen anything like this before. And so the fact that it was the first really digital weapon designed to leap out of the digital world into the physical world, right? So it wasn't just infecting computers. It was designed to physically affect equipment that was being controlled by computers. So to leap out of the digital realm into the physical realm and cause physical destruction. It's not something we'd ever seen before.
It's almost kind of hard to imagine that these kind of units in the US and Israel would have such understanding of even how this kind of particular kind of equipment works. Like I understand that they would understand how to make a worm, but then to go on and understand how a centrifuge works and the kind of hardware of it and how it interacts with a computer, that's pretty amazing if you ask me.
Well, yeah, they put a lot of work into this, and they got the centrifuge knowledge from centrifuges that were retrieved from Libya. So the same centrifuges that were being used in Iran, the design for these, the blueprint and materials, were sold to Iran by A.Q. Khan, who was a Pakistani scientist who stole the design from a Dutch company. And He sold the designs to Iran and to Libya. And when U.S. intelligence and UK intelligence, they infiltrated the supply network for the centrifuges, they were able to halt the shipment of centrifuge parts that were going to Libya and were able to then stop the Libyan nuclear program. In halting that supply, though, the US was able to seize those centrifuges and they brought them to the Oak Ridge National Lab in the US. They set up the centrifuges in a cascade. The initial plan was to just study the operation to figure out perhaps how long it would take Iran to produce enriched uranium material from the centrifuges. But ultimately, that morphed into a sabotage plan. So they just wanted to really monitor the Iran program initially to see how far they were or how far they could achieve with these centrifuges. And then someone got the idea, can we actually affect these centrifuges? And that's where the knowledge came from.
I think what's interesting about what you're saying too is that this is not really a case of a digital weapon operating in isolation. It's really one of the tools that emerged from something that was quite kinetic on the ground. The final solution of this was a digital weapon, but there was a lot of on the ground stuff that happened beforehand.
Yes, and it actually wasn't even the final solution. This was one part of a multi-pronged plan to thwart Iran's efforts to get a nuclear weapon. It included sabotage prior to Stuxnet. There was at least one case that we know of where what's called an uninterruptible power supply, which feeds electricity or it moderates electricity to equipment, and those were sabotaged prior to Stuxnet. And then there were also cases mixed in with all of this of assassination against Iranian nuclear scientists. And then we also saw bombs going off in Iran at some of the nuclear facilities. So there were multiple efforts to thwart this program, and Stuxnet was just part of that.
I would imagine if I was an Iranian scientist, this is kind of the worst job you could ever have because it seems like all of the world's intelligence agencies are ready to use any means necessary to stop what you're doing. Wasn't there at one point one scientist who was killed by a remote control machine gun on the middle of the road somewhere?
Yeah, so this was obviously designed to send a message to Iranian scientists that you are not untouchable, that we can get at you wherever you are. And, these aren't people who are used to this kind of lifestyle, right? They are scientists who are locked in a lab doing their research and to suddenly find themselves targeted, but also, targeted inside the safety of their country. That's really what that was designed to do. There were a number of successful assassinations and a couple of attempts, and it was really designed to send a message to scientists there. Do you really want to be working on a program like this?
Yeah, that makes sense. That makes a lot of sense. And is there any kind of insight into how Iran has viewed this? And of course, they did go to the negotiating table at some point, but there seems to be also a kind of persistence and a dedication. Like in the end, Iran still seems like it's on a pathway to making a nuclear weapon, despite all these efforts, right?
Probably more so now, because in the U.S., the 2007 National Intelligence Estimate had concluded that after the 2003 Iraq War, Iran actually had abandoned its plans to create a nuclear weapon. And so after Stuxnet, Iran actually increased the level of enrichment that it was doing. Prior to Stuxnet, it was doing increasing uranium hexafluoride gas to only between 3 and 5%. And after that, it jumped it to 20%, a huge leap. You need 90% enrichment for a weapon, but doing that initial 20% actually does a lot of the work for you. And so the distance between 20 and 90% is much shorter. And also, Iran, launched their own offensive cyber capabilities program after Stuxnet. So they went on the offense in many ways. But to address your overall question that Iran is persistent and is moving forward, I've just been reading Michael Vicker's book, who was in the intelligence community and a big part of the U.S. intelligence community and a big part of the counterproliferation operations. And he talks about how they knew that any efforts they put into trying to thwart or stall either Iran or North Korea were ultimately not going to be successful. If these countries are really intent on getting a nuclear weapon, they will, and all you can do is sort of stall that process and buy some time.
And that's what they did in this case.
Yeah.
So your book came out in 2015, and then you picked the story back up again a couple of years later, right? With this story of the Dutch mole. Could you talk a little bit more about that kind of wrinkle in the story? And in general, what's left to understand still about this kind of pivotal moment in intelligence warfare, I guess you'd call it.
Yeah. So when I wrote the book published in 2014, and I speculated in the book because we knew that there was only one way for the first version of Stuxnet to get in. It had to be physically carried in. And so I wrote in the book that I suspected that there was some mole that had carried it in on the attacker's behalf. But I didn't know anything beyond that. And then more information about that came out, and I published a story along with a Dutch journalist, and we reported then that it turned out to be a Dutch mole. The US and Israeli intelligence didn't have the access they needed inside the Natanz facility. And they went to Dutch intelligence, who had someone who was actually a Dutch engineer who could get that access for them. And he posed as an engineer, a mechanical engineer. He was able to get a contract to get inside Natanz. And from what we know, he not only deposited Stuxnet in there, but he actually did some preliminary work to obtain some intelligence about the systems that were working inside Natanz, because Stuxnet was a very, very precise weapon. It was designed to only attack a very specific configuration on a system that it was targeting. And by that, I mean it was looking for specific centrifuges at the plant that it was targeting so that it would only unleash its payload, its destructive payload, if it found that exact configuration. And they needed to know what that configuration was. And that configuration is stored inside of a file on the industrial control systems in Natanz. But again, these were air gap systems, so you couldn't obtain this information just by doing cyber intelligence or cyber espionage. You needed some kind of physical access into that configuration file. And we understand that the mole was able to get that to them and give the intelligence back to them so that they could tweak Stuxnet and make it a precision weapon.
What do we know about this engineer and even how he might have got involved? What was his kind of background? Do you think that he was recruited to do this, or he was already kind of in this world and reached out to somebody else? Do we know anything else about him? And what happened to him as well?
Yeah, well, ultimately he died, and shortly after, he deposited this in Natanz, but it doesn't appear to be related to the work that he did as a mole. He died from a motorcycle accident in Dubai. So I think that we don't really know what his prior experience was with the intelligence agencies, whether he had done similar work in Iran for them before. He was married to an Iranian woman. And so he had access in Iran. He visited Iran. He had reason to be there. And it was a good cover. And he was also an engineer. So he had technical expertise to get into places that intelligence agencies would like to get into. And so there are questions about whether or not he actually knew what he was taking in to Natanz, or whether he knew that it would be sabotage, or if they'd told him something else. So we don't know if he fully understood the full danger that he was in doing this operation.
Yeah, I guess it would always make people's imaginations run wild when somebody involved in something like this mysteriously dies. But it's also likely that people have accidents as well. So
It is a strange coincidence, though, and to happen so shortly afterwards. But the thing is that if he were suspected of anything, it is strange that Stuxnet itself didn't get discovered until years after. So if he was indeed suspected of anything, he might have been suspected of something else unrelated to this.
So let's talk a little bit more about digital warfare itself. And also maybe you could explain for the audience what is a zero-day exploit, but in doing so, kind of leading into what is the state of digital warfare today?
Yeah, so a zero day is a vulnerability in software, a security hole in software that allows attackers to use that vulnerability in order to get onto a system and deposit their malware onto a system. And a zero day is specifically a vulnerability that the manufacturer of the software doesn't know about yet. and therefore they can't patch it. And so that leaves it open to attack by nefarious parties for as long as that's unpatched. 0 days at the time, this is really interesting. In 2010, when Stuxnet was discovered, 0 days were really, really rare. You know, malware researchers would look at, they'd find probably and examine 12 million pieces of malware over the course of a year. And out of that, they might find a dozen in a year. Stuxnet didn't use just one 0 day to get onto the systems. It used, that we know about, at least five. And this was the original red flag that tipped off Symantec that they were dealing with a nation state actor here, that there was no way that criminal actors or just even for espionage purposes would use 5 0 days, because once you get an operation discovered, all of those 0 days get burned simultaneously and they're all going to get patched. And so it requires the resources of a party that can afford to lose that many 0 days, but also has the money to either purchase those 0 days, which are expensive, or to put in the research to find them, which take a long time. 0 days are more common now, but at the time they were very rare.
Yeah, what does the market for a 0 day look like? Like if you're a really talented computer scientist in a bedroom somewhere, can you make a lot of money by finding these?
You can. I mean, it depends, but there are 0 days that are, I don't know if you follow all of the mobile phone espionage with the NSO group from Israel and all that, and they're using very sophisticated 0 days in order to get the spyware onto mobile phones. And these 0 days are sold only to, for use by governments. And these can run, a really good 0 day that's going to get you at the core of a system without the user having to take any action in order to get infected, can cost millions and millions of dollars. So it really depends on how many systems it will allow you to get into, the sophistication, the degree of difficulty that it requires for the 0 day to work, and how stable it is. That will it work all the time? And how exclusive it is if you are the only party purchasing it. So there are a lot of factors, but you can make a very good living finding and selling 0 days.
Yeah, those 0 days are the scariest, are the no-click 0 day, where somebody can get into your phone and you didn't even have to click on a bad link or anything. It just happens, right? Those are the scariest ones.
Yes, I mean, and it doesn't even come into a message that you can see. So the 0 day click malware that we've seen in used by the NSO group and others, it comes in sort of a silent message that's sent to your phone, so that you may not even see the message and know that it's being your phone is being infected quietly in the background.
I would imagine in your line of work that you can't help but be pretty paranoid all the time. I mean, not only your knowledge of how the world works on a technology basis, but also the kinds of articles you're writing. Do you find that you have to take extraordinary precautions? I don't want to give away any of your kind of operational security, but do you do everything in person in some sort of wilderness or something to try to avoid these risks?
I mean, so there are different risks, right? There are risks from foreign intelligence agencies, wanting to get information about what a journalist might be writing about. But there are also risks against maybe your own government and law enforcement who might be trying to investigate a leak from sources who might be talking to you. In the writing of the book on Stuxnet, I did conduct a number of interviews in person, left behind all electronics, avoided CCTV cameras in places where I was meeting people. So there are extra precautions that you have to think about these days that you never had to think about before.
Yeah, definitely don't come to London. There's a camera on every corner over here. Uh, I mean, dude, that's actually kind of a practical question, but let's say that you're a business person, you're a journalist. I mean, what is the safest sort of setup that isn't really difficult to do? I mean, is there any kind of best practices that you would offer someone who's not going to be a professional, who's not going to, take 2 hours to get to a meeting the long way or whatever?
I mean, in person is always the best at this point, but you have to make sure that you're not carrying your electronics with you. You do have to shut those down or leave them at home. I had interviews where I paid cash for a taxi. There are things that you really have to think about in terms of the electronic footprint that you're leaving.
Yeah, the other thing is there's a lot of kind of, I mean, I would imagine sort of myths of security. So, Everyone likes to use an app like Signal, but in reality, Signal can be just as vulnerable as anything else. Maybe it's hard to intercept the messages between two phones, but if you get access to the phone, you've got access to everything, right?
Well, yeah, that's the case for anything that's using end-to-end encryption. Your laptop, your phones, if it's seized and someone can get into it using the password or bypassing the password, they're going to see anything that's unencrypted on that device. So Signal, you can actually set your account to delete messages after 5 minutes or an hour or a week. So you can get around that as well, by just not storing anything on your system. But none of this is convenient, and that's the whole point about security. Security is not convenient, and that's why a lot of people don't take security measures, because it adds extra layers that you have to involve.
I would love to hear more about your journalistic process because, on one hand, when you're actively seeking someone, that leaves a mark, to reach out to somebody or contact them. And then if people are trying to contact you, that's also could be risky. And I'd also just be interested to hear a little bit about getting people to help you with these really important stories, but there's a lot of risk involved. What would you describe your style as a journalist?
I think it really the story dictates that, and the source dictates that. You use different methods depending on what the story is and what it requires. There are cases that it starts for me with documents. Maybe a source will supply me with a lot of stuff that I need to look through and dig. In other cases, I go to a lot of conferences and I meet sources there, and especially government sources, because they're coming to conferences without their handlers quite often. And so you can get people without the front office in front of them, right? You can get them directly. And they tend to be also a little more relaxed about, engaging with you. I love, in person, a lot more. I mean, obviously the phone is convenient, but there's nothing really that replaces in person.
In the last recent couple of years, you've been focusing on election security and other topics. Could you just give us a little glimpse of things you've been focusing on?
Well, since Stuxnet, I focused a lot more on nation state activity. So, looking at nation state espionage and also digital attacks. With the war in Ukraine, I focused a lot on the activity there and looking at what the repercussions are for future conflict, perhaps with Taiwan and in other places. So, I think that that's really interesting, is sort of to watch that activity in that space of how that's going to be developing, because Ukraine didn't develop the way we all anticipated would. So that's a lot what I focus on right now, is nation state stuff.
And if you were to kind of really articulate the most pressing topic within the world of digital security today, is there something that comes to mind?
I think that something that's not well understood or being addressed is integrity of data. So we focus a lot on the theft of data. We focus a lot on ransomware, which is sort of the denial of access to data. But we haven't really looked at the integrity of data. And by the integrity of data, I mean a number of things. I mean, simply sort of changing like election results in a computer. That's integrity of data. But also changing the software that's used in a voting machine, or changing the software that's used in an accounting application. Those can have huge repercussions, and they can be done silently and invisibly and undetectably. If you imagine all of the financial software that we use and what could potentially happen in situations like that, or weapon systems now use software. And if you can get into the supply chain and be altering weapons in ways that they don't work in precise ways that they should. So I think that those kind of integrity attacks are something that need more attention.
Well, thank you so much, Kim. And how can people stay in touch or with your work and follow you in general?
Well, I'm on Twitter, so people can follow me there. I'm on LinkedIn, and I do publish my own stories through, it's not actually a newsletter, but it's called Zero Day.
Great. Thank you very much, Kim.
You're welcome. Thank you.
That's it for this week. Thanks to Kim for joining us. You can find Kim on Twitter. Her handle is at Kim Zetter, and you can subscribe to her newsletter at www.zetter-zeroday.com. The best way to stay up to date with whale hunting is to hit follow wherever you listen to podcasts, and you can also subscribe to the whale hunting newsletter for updates on the shadowy lives of the powerful and ultra wealthy at whalehunting.projectbrazen.com. Thanks for listening, We'll be back next week for more.
Whale Hunting is a production of Project Brazen. It's hosted by me, Tom Wright, and Bradley Hope. It's produced by Megan Dean and Claire Urban. At Project Brazen, Mariangel Gonzalez is our project manager, and Megan Dean is network manager. Ryan Ho is the creative director, with additional design from Andrea Claridge. For more from Whale Hunting and to subscribe to our newsletter, visit whalehunting.projectbrazen.com. Subin Kim, Georgia G, and Clara Preve are reporters for Whale Hunting.